French! Why do you think I have this outrageous accent, you silly king? You don't frighten us, English pig dogs! Go and boil your butter!
Well, hello again everybody. And for me, very shortly, it's going to be my annual pilgrimage to go and watch the classic Le Mans in France.
When the greatest sports car event of the year, the Le Mans 24-hour race, opens in brilliant sunshine.
Now, I don't know about you, but I absolutely love France. It's an absolutely beautiful country, only spoilt by the presence of the French. Now, for the British, abusing the French is almost kind of like a national sport.
We are the French, retreat is what we do not need the red and blue. Red and blue.
Bonjour, you cheese-eating surrender monkeys!
Miss, were you in hello, hello? No, miss, say good morning. No. Go on, just say good morning.
No.
Miss, have you got hairy armpits?
I beg your pardon?
Are you scared of razors, miss?
No, I'm not.
Are they expensive in French land?
No, they're not.
French women never shave their armpits. Be seen with a woman with a forest under her arms. Everyone will instantly mistake you for a real French person.
So, just to help me do that, I've bought this megaphone bullhorn. And we have the, what do you call that, a pile, I suspect it is a pile, and it's a PMP40, megaphone bullhorn, and it's a bullhorn with siren and handheld microphone from pileusa.com. And, well, just looking at it, it's actually manufactured in China. It's got a plug-in handheld microphone. It's got a built-in automatic silence function. The range is up to 1,000 feet, so even the deafest of Frenchmen should be able to hear us. It's for indoor or outdoor use, and apparently it's as used by the US Armed Forces. Very impressive. Adjustable volume, compact, portable, durable, and maximum power output is 40 watts. Note it does say maximum. I'm wondering, are those Chinese watts or British watts? There is actually a conversion factor. To convert between Chinese watts and British watts, you actually just multiply by a third. And we've got an ergonomic pistol grip and lightweight chassis. Batteries required 6D type. Yeah, so of course I did have to go and buy 6D type batteries, the outlay of which is the GDP of a small country. And the dimensions are 8 inches by 13 inches and the weight is 2.2 pounds. Little handheld microphone, feels quite nasty. Well, it is at least reassuringly megaphone shaped. Oh, that's where the batteries go, it looks. Let's put some batteries in it. So on the top we've got an on-off button. Feels quite nasty. Got the alarm button, got a music button. What the music does, don't know. We've got a volume slider, and I'm guessing that's where the microphone plugs in. Okay. And press that, and we've got a little flip-up battery compartment there. So it looks like we've got negative, 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 and positive, positive. Ooh, quality. Can you hear me, all you French cheesemongers? Well, hopefully you can see into the bottom of my dark hole, but there's a Phillips head screw down here. And I'm just going to try and undo it because I'm hoping we're going to get some access to the internals. Because what I'm hoping we're going to be able to find here is the terminals to the actual speaker part of it. Because what I'd like to do is try to measure the, if we can, I'd like to try to measure the output power. Well, I'm afraid I am fighting with this a little bit. I'm just trying to get the these clips off that are holding the speaker in, and it's some kind of a little bayonet fitting, and yeah, it's a bit fiddly. probably not that hard when you know how to do it, but when you don't know how to do it, it's a bit fiddly. Nothing that a bit of brute force couldn't fix. Okay, I think we're getting there. I'm guessing you'd call this a horn speaker, wouldn't you? So I assume when I take these screws out we're going to find some form of diaphragm. Now the only reason I'm actually taking this apart is because I can't get to the connections at the back of the speaker. Oh, didn't want to do that. That's exposing all the voice coil. Yeah, going to screw that up quickly and say nothing. I don't know if you can see there, but I haven't got enough cable to pull this horn speaker out, and it won't withdraw the other way. So what I'm going to do is I'm going to cut these red and black wires which are feeding the power to the horn speaker, and we will. What we'll do is we'll just join them back up later with a bit of extra cable length. The question is, can we get a pair of cutters in there? We will join you back up later. I think we might have got it. Okay, so here's a close-up look at our beautiful little horn speaker. It's got quite a powerful magnet on the back there. So basically we've got quite a big powerful magnet on the back here, and then inside there, which I'm not going to remove because I don't want to destroy the thing, we've got a voice coil, and then we've got, looking down there, it looks like there's some form of plastic diaphragm. So it's pretty much just a normal speaker. So we've got this black canister here, which just looking at that is just it's just a battery compartment. It doesn't do anything but work as a battery compartment. And then we've got this other part here which must contain all the electronics. I wonder if we dare open that. Yeah, let's dare open that. Now I've just put a little mark on it because you can bet if it's possible to get this thing, you know, 180 degrees out of phase, I will do such. So here are our push buttons, which I think that was on off. That was that music or siren? I think that was siren, and that was that wonderful little music control. There's actually amazingly little on this, or it appears to be very little on it. Here's our variable potentiometer, our slider pot. We've got 1, 2, 3, 4, 5, 6 large power supply decoupling capacitors. Got a couple. Well, we've just got one little ceramic capacitor there. We mentioned our little toggle switches. There's our little jack connector here for our incoming microphone. We've got an LED. And I didn't spot these at first, but we've got two boards here, and they're the ones with the little black blobs on them. Do you call those cobs? I'm not sure. Is it chip on board? I don't know. Somebody will correct if it's wrong. Basically, there's going to be an integrated circuit on there. So although you can actually only see, you know, just a few components on here, you know, there's probably many thousands of transistors in these little audio ICs down here. And I'm guessing that what these are going to be the tone generators. These are the things that are making that horrible siren control, or actually generating the music output. And I'm guessing because this has got two music out, well, one's a siren and one's music, I'm guessing one of those chips does each of those things. But the real meat and drink of this is the audio amplifier, which is down here, which is, for those playing along at home, is a TEA2025B. So I'll just say that again, TEA2025B. So if we just take a quick look at the instructions on the box here, I do distinctly remember it said that the output power was 40 watts. Now, it does say maximum 40 watts, but 40 watts nevertheless. Oh, there's something burning. I can smell something. Oh, what's that horrible smell? Not me. Well, you know what? I think the smell's coming from this little audio amplifier, and it's got that unmistakable aroma of I think it could be bullshit. Well, I've just looked at the data sheet for this little audio amplifier, this TEA2025, and it describes it as a dual or bridge connection mode audio amplifier. So you can either well, basically it's a stereo amplifier, and you can either have you know, two outputs to give it a stereo, or you can actually bridge both the outputs for a single high power mono output, and I'm guessing that's what they will be doing here. But if you actually just go back to the description of the device on the Rapid website, it describes it as a 4.7 watt stereo audio amplifier. It's not dead clear to me if that audio output is is the total output for the two stereo channels, or if that's the bridge configuration. So without reading the datasheet and actually trying to figure that out, I think what I'd like to just do is have a go at measuring it. So I can also spy in the bottom of the case here, we've got this little condenser microphone, so we don't have to use the external microphone plugged into the audio jack. We can actually use this little condenser mic as well. Drop these extortionately priced batteries back in. Oh, done that wrong. Schoolboy error. Forward. So we're going to take our power measurement, but I'm not exactly sure what the impedance is of our load here, so let's just measure that. And of course I'm going to get hundreds of comments saying that, oh, you can't measure the resistance of a speaker coil because it's an impedance and not a resistance. Well, I'm telling you, I've measured hundreds and hundreds of speakers, and generally the DC resistance of a voice coil on a speaker is exactly what it's printed on the back of it. So if it's printed as a 4 ohm speaker, 9 times out of 10 it will come out of 4 ohms. If it says 16 ohms on the back and you measure it, it'll come out at 15.8 ohms or something very close. So I'm guessing by this is going to be a 4 ohm speaker. If you don't agree with it, don't bother leaving it in the comments, because that's what I do and it's always worked for me. So it's given us 3.8 ohms. So the audio output that would normally go to our speaker, we're going to connect that to our little audio analyzer. And what I think I'll use to take the measurement is a sledgehammer. So let me go and find one. Well, cast your eyes over this sexy little temptress. And here you see my HP 8903 audio analyzer. And you've got to admit, she really is a fingered beauty, isn't she? So what I've got set up at the moment is we've got the output from the signal generator here, and it's connected into the microphone input of our megaphone, and then where we had the speaker connected to the megaphone, I've got that going into this dummy load, this audio dummy load that we built. And again, I've got a video on how to build this and I'll put a link on there. And this audio dummy load, it's got an 8 ohm setting and a 4 ohm. And at the moment I've got it set to the 4 ohm because we kind of estimated that the horn speaker, which we've got here, we estimated that the horn speaker was probably about 4 ohms. So yep, that's what we're going to say, it's 4 ohms. So we've got that set to 4 ohms. There's just a big set of resistors in here, and they're mounted onto the back of an heatsink. I think this thing off the top of my head was good for about 100 watts, and I've got a feeling we're not going to approach our 100 watts, and yeah, I don't think we need to worry about that. So we take the audio out of the dummy load, and then we're just taking it into the measuring side here, into the input. Now I don't know if some of you with keen eyes have spotted this, well, it looks like a big licorice allsort or something. It's and what is it? It says it's a bumper high quality noise suppression isolation transformer. Okay, so the reason I've got this isolation transformer plugged in is for two reasons. One of them is that because this uses an electret microphone, it puts about 3 volts bias on the microphone leads, and I didn't know whether or not that was likely to cause a problem to this audio analyzer. So rather than possibly risk damaging the signal generator output by putting 3 volts DC onto it, I just thought it would be better to use an isolation transformer. But the second reason I'm using an isolation transformer is because the amplifier inside the megaphone uses what they call a bridge configuration. What that means is, although this speaker, for example, has got a plus and a minus on it. The actual minus, the black wire, the 0 volts, it's not actually referenced to ground. Both of the drive wires go to 2 separate pins on the chip. So what you would do is, if I actually just plugged in the analyzer to the speaker connections here, what I would find was happening, I would end up shorting out the output from the amplifier. So what I'm actually doing is I'm actually just breaking the ground loop, if you like. You can do it on either side. You can actually break the loop on the input side, or you could break the loop on the output side. But I've chosen to break the loop on the input side because I don't want this this transformer here giving us misleading readings for any any power readings we get, because this only has to pass the a signal level. It doesn't actually have to pass any power the way I've got it connected at the moment. So I hope I've explained what that's for. Probably not very well, but that's what it's for. So we've also got the oscilloscope set up at the moment, and that's also just measuring the output from the megaphone. I'm going to turn the unit on, so it's switched on now, and now I'm just going to turn the volume control up. So there we go. I'm going to turn it up, and I'm going to just turn it up until we start to get some clipping, and I'm going to call that the maximum. So that's squaring off now. So I'm going to come back a bit. Let's just square it off. That's completely square. I'm coming back. I'm going to say that is our that's our maximum output level. And here's the RMS output voltage that we're measuring from the megaphone's amplifier. And I don't know if you can see, the voltage is dropping all the time, and I've linked that to the chip is actually getting hot. So I'm just going to take it off and let it cool down again. Now, in some ways, I'm not surprised that the poor little chip is getting hot, because I'm guessing in the real world you wouldn't be driving it so hard. The amplifier is probably not like 100% rated to be running at full power constantly, because music and speech has little gaps in it, doesn't it? Okay, so we'll switch back on and take our measurement. Okay, it's dropping all the time, but I'm going to give it the benefit of the doubt, and let's call it 4.11 volts RMS. Well, according to the instructions here, the maximum output power is 40 watts, and well, I don't know, maybe they've fallen out in the box, because we're missing about 35 watts somewhere, aren't we? No, they're not in there. Now, of course, I would never accept my explanation for this type of power measurement, because, yeah, I get a lot of things wrong. Now, I wouldn't blame you at all if you don't trust any of my calculations, because, let's face it, I'm not very good and I make a lot of mistakes. But you may not trust me, but what you could trust is the actual 8903, because what this can do is it can actually display the output power in watts. So what we have to do is we have to tell it what the speaker impedance is. So to do that, we've got to invoke one of these special functions. So it's got this little crib sheet here which you can pull out. That's the error code, so we don't want that one. Get out. We want to display the level in watts, which is special function 19. So what we have to do is we have to type in the number 19 and then the number of ohms that the speaker is. So let's try that. So get in. Okay, 19.004 ohms, and then we press the special function button, and the special function button lights up here just to show you it's doing something a bit special. So let's turn the megaphone on again, and the display here should be the maximum output power. So let's have a go at that. And 4.2 watts, and it's dropping. So we'll just leave that on a second, and you're going to see the amplifier fall back to protect itself, because that 2025 power amplifier chip is going to fall back because it's going to heat up and it's going to go into thermal overload, and it's going to fold itself back, which you can see it doing there. There we go, it's just folded back to protect itself. So I think our audio chip must live under here somewhere, because I can actually feel the plastic enclosure. It's actually getting hot in this area here. So in some ways that little chip's quite good, because it is protecting itself and nothing's blowing up. So yeah, that gets a thumbs up for that. Well done. So what I've done now is I've actually turned the volume control down on the megaphone. It's just about a quarter of the way up now. And again, I just thought what we could do is we can try taking a distortion measurement, because I've never done that before, so I'll be quite interested to see how well that works. So as far as I know, all we've got to do is press the distortion button. And it should be giving us a direct readout of the distortion. So let's just switch it back on. And there we have 14% distortion. Now if we actually turn the amplifier up, I would expect it to start to clip. So let's have a look at that. So that's quite interesting. As I slowly turn up, the actual distortion figure seems to go down, and then all of a sudden it very rapidly climbs back up again. So we've got the megaphone turned about quarter of a way up there, and it's actually showing that waveform as being 15% distorted. And I think you can see that it's kind of rounded at the top and sharper at the bottom. And we can also see about halfway up there we're getting some crossover distortion, and I'm guessing what's inside one of these amplifiers, it's probably some form of like H-bridge arrangement. So I think we've got some crossover occurring there. So let's turn up the amplifier up a bit more. And that looks a lot more like a sine wave now. Oh, but we've folded back again. And now it's folded back, we're showing 27% distortion. So it's going to fold back, there it goes, and it's protecting itself, but the output waveform will be totally distorted. So there's two ways you can wire this up. We could have wired it up in the stereo application here, because it's 2 channels, or the bridge application, which in this megaphone here, I did have a quick check of it, and it is wired up in this bridge application now. It says that the maximum output power that you can get is about 4 watts. Well, it's actually doing better than the data sheet says, because we're actually getting 4.2. But what we aren't getting, again, is the 40 watts that it says we should be getting in the manufacturer's literature. So it looks like the conversion factor between watts and Chinese watts is about 10:1. Not satisfied with your product? Tell us why, and we'll try to make things right. Okay, well, I can't be bothered writing a long explanation. Let's just say 4.2 watts, not 40 watts. And for now, I think that'll do. Bye bye.